Hey guys, welcome back. So we're going to continue on with our stats analysis here. So this is lesson 6.06 and we are looking at two variable data. Sounds really fancy, but do you remember scatter plots from last year? You know, where you have two data sets, you put one on the x-axis, you put one on the y-axis, and you draw dots and you connect them. So that's what we're doing today. Something to think about, representing two data sets together on a scatter plot. That's what we're doing here today. And scatter plots are a great way to show trends and outliers. Now you can take a scatter plot and look at it to find all those things we've been talking about, like mean, median, mode. You can see outliers, you can see trends, all that kind of stuff falls into place with a scatter plot. So I've got two blank graphs here. One is shoe size to height, and the other is weight to workout time. Well, let's talk about the shoe size to height. Let's say you went, and we would have done this in the classroom. We would have, figured out what's your shoe size and how tall you are, and you would probably expect that you would get data that would look something like this. You've got all these dots going along here, like this. The idea is that the taller you are, the bigger your shoe size. And so you get this trend in the data, something like this. So as your height increases, so does your shoe size. Now, the other one, the workout time and weight. Now, this is going to assume that you're going to the gym to lose weight. Obviously, if you're a bodybuilder and you go to the gym, you're going to gain weight. But so this is someone who's trying to lose weight. And when they first start out, it's kind of high. But the more they go to the gym, the more they lose weight. And so they get what's known as a negative trend. And so theirs is going to look like this, where the slope of the line is negative. Over here, the slope of the line is positive. So we actually call this is a positive association. And this is a negative association. All right. Now, when you're doing this, notice that my points really were consistent and that it just formed a straight line. And this one formed a straight line. But sometimes when you're doing experiments or you're collecting data, you don't get that. So we need a way to show how close the dots are to forming a straight line. And that is our correlation coefficient. So we're going to be talking about correlation coefficient here. Let's just switch colors for fun, make it Technicolor. If you do a data collection and you get points that actually do form a straight line, and when you're doing science and stuff, the chances of you getting a straight line are pretty minimal. But if they form a straight line, then what you're talking about is you're getting a correlation coefficient, and we say that with a C, equal to a positive 1. Now let's go to the far end and we do this, where you collect points and the points almost exactly line up in a straight line, but in a negative slope. Well, this would be a correlation coefficient equal to negative 1. And then in between, you just get this scatter, this what looks like a shotgun pattern, where it's just a blob of points. And this has a correlation coefficient equal to 0. Now I've shown you the middle and I've shown you the extremes, and you can get anything anywhere in between, okay? In between 1 and 0 might be something that looked like this, okay? And in between 0 and negative 1 might be something that looked like this, okay? Where the points are more scattered, they're more spread apart. And so this is a correlation coefficient of 1, but this might be a correlation coefficient of 0.5. Then you've got the 0. Then this might be a correlation coefficient of negative 0.5, and this would be a correlation coefficient of negative 1. That all wraps together this way. The correlation coefficient describes how close the data points are to forming a straight line. And the correlation coefficient is between, so it's -1 is less than or equal to C is less than or equal to 1. So C is between and including -1 and 1. And we say that the absolute value of C approaches 1, but it doesn't go beyond 1. All right, that's it. It's a very quick lesson, but it should be enough to get you going on the suggested problems for this. Go ahead and do them. Feel free to work with a friend as you go through these problems. If you have any